Let's go over the product rule. And the product rule is for derivatives, so hopefully you are deriving some things. Hopefully not that big. And essentially, let's say you have some function. We'll call him f of x. He's a happy little guy. And let's say f of x happens to be the product of two other functions. Now, g of x and h of x could be anything. Like for instance, let's do this over here. We'll make up a practice one. So let's say we have the square root of x times, it doesn't matter, tangent of x. So you can see we are multiplying two functions here. So f of x is the product of two functions, root x and tangent x. And now that you know this rule here, now that you've done this in class, anytime you derive a function, you've got to be looking, do I have a product? Because you have to use the product rule. And here's what the product rule says. It says if you want to derive f, which is f prime of x, which really means we're finding a function that finds the slope of f, same thing. What you do is, I'm going to make a mistake here. Ready? Watch this. I'm doing this on purpose. I'm going to write it down here. It is absolutely not the derivative of g times the derivative of x. It'd be great if that worked out. That'd be awesome, but that is not good. Do not do that. That's bad. Okay, not good, bad. Okay. So, what you do, get it, huh? What we will do is derive g of x first. So g prime of x multiplied by the second function. So we derive the first function, not the second function. Plus, now we're going to derive the second function times the first function. That's the rule right there. That is called the product rule, and that is how you derive products. And it really, I mean, it's not really that bad. It's four things. Derive the first times the second, that's 2, plus derive the second times the first. So if we want to derive this function over here, then f prime of x is just going to be, we got to derive this first function. Well, this is the same thing as x to the 1/2 times tan x, just to make it look a little bit nicer. So we haven't derived it yet, I just rewrote it. That's what f of x equals. Now f prime of x, it's slope function, if you will. We're going to derive the first thing. Now the first thing is h of x. Maybe we should do this in colors. Here's h of x, or x, good God. The first thing is x to the 1/2. We got to derive that using the power rule. So the power rule says, take the coefficient, which in this case is just 1, multiplied by the exponent. That's going to give us 1/2 x. And subtract 1 from the old exponent. Well, 1/2 minus 1 is negative 1/2. And then multiply by that second function, which is tangent. Well, we're not deriving tangent, so just multiply by it. There you go. Now, plus, I'm going to move it down here. This should be in one straight line, but I'm running out of room. So, plus, now we're going to derive that second function, which is tangent of x. So that's going to give us secant squared of x, because that's the derivative of tangent. You should know that. Times that first function. Not the derivative of the first function, just the first function, which is the square root of x, or x to the 1/2, however you want to write it. And if you've got a teacher who's a stickler, who doesn't want negative exponents or something, which I am one of those dudes, rewrite it so you don't have any negative exponents, times tangent, so you can really just put tangent on top here. So like that. Plus, you should put the root x out front, secant squared of x. That's how product rule works. Derive the first thing times the second, plus derive the second thing times the first, as long as you're multiplying them. Okay, and you're probably saying, why? Why is it happening? Well, I went over this in class. We'll walk through the proof again right here. Why not? So, here's the proof. If f of x is, what do we say, g of x, h of x, then to find f prime of x, we're going to use the definition of derivative, which is the limit as not h, or not x, we want h in there, as h goes to 0, h goes to 0 of f of x plus h minus f of x over h. Now, we're just going to plug in f of x plus h. If f is g times h, then f of x plus h is g of x plus h times h of x plus h. No problem. Let's do this in colors here. So we're going to get, well, where are you at? There you go. Is the limit as h goes to 0, and we'll keep these guys separated by color. So we're going to have g of x plus h times h is probably a bad letter for this since we got another h in there. Let's make this, instead of h up here, Let's cross them out. Sorry, it doesn't really matter. I just don't want you to get confused with the letters here. So let's make it G times, it doesn't really matter, K. G times K. I like using H because FGH. It doesn't matter. K, there we go. So our next function, we'll do him in blue. So now it's going to be K of X plus H. And all that is F of X plus H, because F is G times K. So Gx plus H, Kx plus H. Minus F of X, which is just this thing, G of X, K of X. So G of X, K of X. And all of that is over H. I keep changing color here. Try to make this look a little better. So really we've got these two functions all mixed up here. We know what the rule already says, and this is what really happens here. Check this out. You're probably, I don't know if you're going to like this or not. Someone much smarter than myself thought of this. Since we're trying to get this down to the derivative, and the derivative looks like f of x plus h minus f of x over h, we would like to get g of x plus h minus g of x over h. Now the problem is we got this k of x plus h here and this k of x here. We can't really get rid of those. As much as we don't like them, we want to kick them out. We can't. So the trick is we are going to add and subtract the same thing. And it's going to work out super nice. So we have g of x plus h times k of x plus h. Again, only using different colors here so that you can see which function's where. And now I'm going to subtract off g of x times k of x plus h. So I'm adding this to the function. I just put that in there, subtracted it off. But if you subtract it off, you got to add it back on. So now we're going to add on g of x times k of x plus h. Now I'm adding him in there, that's fine. So they would really cancel out. If we wanted to, we'd cancel them out. That wouldn't make any sense though, because then what's the point of adding them in there? And then minus g of x, k of x. And all of this is over h. Now, since we're adding, you're allowed to split up a fraction like this. So I can put this part over h and this part over h. And it's really the limit of this whole gigantic nasty mess. Okay, so here's what we're going to do. You'll notice in this fraction over here, we have k of x plus h and k of x plus h, and we can factor out. Over here, we're going to have g of x and g of x. We can factor him out. Perfect. So let's do this. We're going to factor out, well, let's write this again, limit. Probably sound like I'm crazy doing this, but that's okay, I don't mind. Limit of, we're going to factor out k of x plus h. K of x plus h. And then what's left in red is going to be g of x plus h minus g of x. And all of this is over h. Now, since we're multiplying here, I can say this part's over h and this part's over 1. Okay, so really we'll put another parenthesis in here. We have this going on. Now I haven't really changed anything. If we multiply this together, k of x plus h distributes, which gives us g and k x plus h right there, minus g of x, k x plus h. That's great. And if you multiply the bottoms, you get h. So it's the same exact fraction. Didn't really change anything. Plus, now on the other side here, we can factor out that g of x. So we're going to factor out g of x, and what's left is going to be k of x plus h minus k of x. And same thing, this is all over h as well. Well, I'm going to leave this over h and just put g of x over 1. So essentially you're multiplying this right there in that parenthesis. Okay, and now let's do this. This is going to work out very nicely for us. As h goes to 0, well, k of x plus h just becomes k of x. Times this whole mess here, we'll box it off in green, this right here is the difference quotient. And if h is going to 0, which it is, we got a limit, still inside the limit, then this is the same exact thing as the derivative of g. Hallelujah. It's just g prime of x. Plus, g of x is just g of x, ain't no thing, times, now we have the limit h is going to 0 of this thing right here, this big fraction. Well, what is that? That's just the derivative of a k. K of x plus h minus k of x over h is the difference quotient. If h goes to 0, it's called the derivative. So that we represent that with just q prime of x. And there you go. There's your proof. We did it. And the whole trick was starting with a definition of derivative and then adding in this term and subtracting it off. And then allowed us to separate the fractions, which turned into these perfect derivatives. Amazing, I know. Good day.